Hello everyone. So today we are going to see the weekly contest 422 of Leetcode. So here the first question is check balanced string. So here we are given a string and it is consisting of only digits and we have to calculate whether it is a balanced string or not. So how it is balanced or not, it is be checked by a string of digit is called balanced if the sum of digits at even indices is equal to the sum of digits at the odd indexes, right? So for example, here it is given 1 then plus 3 is equal to 4, and when we do the even positions, then 2 plus 4 will become 6, right? So 6 and 4 are not equal. That's why it is not balanced and we will return false. But in case of this norms, in example 2, we can see that 2 plus 1 plus 3 is equal to 6 and 4 plus 2 is equal to 6. That's why both odd indexes positions element and the even indexes positions elements summing up to 6 and it is balanced, so we have to return that only. So here we will code it out. Firstly we will take an array of character where we will convert our num to char array, and we will keep track of int of even positions and odd positions, the sum of even positions and the odd positions. So here we will traverse in this array ch, so it should be as c, and if we have to keep track of one index, so I is equal to 0, and if I divided by 2 is equal to 0, then we will make sure that that should be added in the odd positions. So odd plus, here we will keep c minus 0 because we have to convert the correct character to the integer also. That's why we will keep c minus 0 in character form, otherwise it will be added in the even position and it will be c minus 0, right? And at the end we will just return whether even is equal to odd or not. Okay, wait a second. Yeah, we have to increment I also, so it should be incremented each and every time. Yeah, let's submit it. Okay, here we can see it got accepted. Let's go for the second question. So, find minimum time to reach last room, and it is of variation 1, and the third question is variation 2, right? So, here we can see these two questions are very similar. There is very little variation between these two questions. We will first see this second question, then we will move to the third one. So here it is given there is a dungeon with n cross m rooms arranged as grid, and you are given 2D array move time of size n cross m, and where move time of ij represents the minimum time in seconds. Here you can start moving to that room. You can start from room 0 comma 0 at time 0 and can move to adjacent room. Moving between adjacent room, it takes exactly 1 second, right? So when we will start from 0 to reach 0, we don't need any extra time. The time will start from 0, right? But when we are going to the adjacent room, then it will take 1 second plus if the total time delay is less than the time required to reach that adjacent room, then we have to consider that which is required to go to that room, right? So here we have to return minimum time to reach room n minus 1 comma m minus 1. We can see we have to find minimum time to reach the bottom right corner. So in the minimum time, how can we reach? We can think of something shortest time needed, right? So when we are seeing that we need shortest time and it is something like we have to travel, so we can think of shortest time or shortest distance like things. So certainly we will come up with a solution of this Strass algorithm, and using some priority queue based on how much time it is requiring, and if the adjacent node which is requiring less time, that should be given more priority, right? So this type of approaches are coming initially. So let's see whether this approach is really working or not. So here we will go with the first example. Here we are given 0 comma 4 and 4 comma 4, right? So from when we are going to 0, it is at time 0 we reached to this particular grid 0 comma 0 at time 0. But when we want to go to this 4, then we need time at least 4. So when time is equal to 4, then only we will go to this cell, and to travel to this cell will also take 1 second. So from 0 to this cell, this will take 4 plus 1 means 5 seconds or 5 unit times. Then from this we can see when we reached to this cell, then time delay is 5. 5 is total time delay till now, and from this 4 we are going to this 4 means the last cell which is our destination. To go to this cell, the travel time is 1 second, and 5 is already bigger than this current value, this destination value. Our delayed time is already 5, and this cell is requiring only 4. So here we can directly jump from this cell to this cell just by adding 1 to it. So 5 plus 1 will need 6. So in 6 unit time or 6 second, we can cover this distance from 0 comma 0 to n minus 1 comma m minus 1. So here it is given that minimum time required in 6 is 6 second, because at time t is equal to 4, move from 0 comma 0 to room 1 comma 0 in 1 second, and then from 1 comma 1 to 1 comma 0 to 1 comma 1 in 1 second. That's why this 1 second plus 1 second, 2 seconds are required, and initially we required 4 seconds to wait here. That's why total 6 seconds required to travel the whole distance, right? Let's go for the example number 2, and here we can see, here it is given time required, all the cells requires 0 0, right? This is an interesting test case. Let's see this and understand this problem. So here it is not like we are just going to check only 4 and then we will just traverse. We have to check all the possible ways, but we will prioritize the lesser distance or lesser time taken by any grid. So we can either, here also we can either traverse from 0, then this 4, and then this 4. This way is also possible, and this is also possible from 0 comma 0 to 1 comma 0, and then from there we can go to 1 comma 1, right? So in the similar possible way, there are so many possible ways, but we will choose the shortest time required path. So let's suppose in this problem, we are here at time t is equal to 0. From this we need to traverse to this, so we will traverse to this grid by 1 second or 1 unit of time. Then our time delay is now 1 second, right? And from there, here we can see our required time is 0, so we can directly jump to it. Then here also we can see our required time is 0, we can directly jump to it because delayed time is already 1. We can directly jump to it by adding 1 in our delayed time. So now time will be 2 seconds. From here we can come here directly because it is also required 0 delayed. So already we are at time t is equal to 2. We can directly jump to this, and we will just add 1 because traversing time from one cell to another cell is 1 second. So total here will be 3 unit of time or 3 seconds, right? So this is how we get that from traversing one cell to another cell, how much time required in shortest possible ways. Let's go for the example 3 also and understand this. So here in this test case it is given that, okay, here also we can see that at 0 comma 0 we are at this position at t is equal to 0. Even though it will not be 0, then also we can stay here at t is equal to 0. And from this to this cell we required how much time? Already we are at t is equal to 0, but we have to wait to 1 second because to travel to this cell we need at least 1 second, right? But at t is equal to 0 we are at 0 comma 0. So when t is equal to 1, then we will take 1 second extra to travel this. So now our time will be 2 seconds because 1 second we stayed at 0 comma 0 to come here, and then 1 second required to traverse to this cell, right? And from this we can see that our delayed time is already 2. So delayed time is already 2, and here also we require 2. So we are already fulfilling this. So we will directly jump from this cell to this cell by adding 1 to it. That's why it will take 3 seconds, right? We can start with 0. We are starting with 0 because uh, at 0 comma 0 we are having 0. It's not the case. Even though the test case will be like, okay, let's suppose the test case is like 90 comma 8 comma 7. Let's suppose this is the first uh, grid, and then another is 20 comma 1 comma 3, right? So in this cell, currently we are having 90, but at t is equal to 0, we will start from here and we will check whether 8 should be taken first or 20 should be taken first. Here, let's start to code it out and we will see the priority queue, how we are going to implement this. So, firstly, we will take the n is equal to move time dot length and m is equal to move time of 0 dot length, and we will take priority queue. Inside this we will take a tuple where this tuple will contain the value of grid position and the time required. So grid position can be expressed in terms of I comma j or row or column. So that's why three requirements will be inside this tuple, and this tuple class will be implemented here only. So here we will define our priority queue as new priority queue, and this will be sorted based on time factor. So here we will take x comma y, and this lambda function will sort all the values based on time factor. So firstly let's make the tuple. So class tuple, and now we will keep a distance array such that even we are traversed some grid that should be tracked. If that grid is tracked with more number of times required, then only we will go and update that with smaller time if possible. So we will keep this. So, okay. So, I have made a mistake in the time. So, here let's see the constraints as well. So, constraints are important here because here it is given that movement time length should be from 2 to 50, and movement time of I of length should be also from 2 to 50, and the value should be from 0 to 10 to the power 9, right? So in case of whenever we are trying to define the distance as infinity, right, in case of the Distress algorithm or any graph related problem, we used to give infinity initially. The distance should be infinite, and then we will try to minimize that. In such case, we directly don't give value as integer dot max value. This type of convention is not there because whenever we will add the distances between any two nodes, then the limit can surpass, right? Limit of integer can surpass that. That's why we usually give 10 to the power 9. But in this case, the movement time of I comma j is already can be 10 to the power 9, right? So in that case, for example, let's suppose there is a test case like this. Uh, 10 to the power 9. Let's suppose in shortcut I will write 10 to the power 9 and then 10 to the power 9, and here also 10 to the power 9 and 10 to the power 9. Okay, so what will be the answer here? What will be the scenario? So here in t is equal to 0, we will be at 0 comma 0, and to traverse to this we need to wait at least t is equal to 10 to the power 9 seconds, and then we will add 1 to it, and then we will go to another in this cell, right? So, in case of like priority queue or this RAS algorithm, we generally used to give the infinite as 10 to the power 9. So, I have also given in the contest as 10 to the power 9. So, whenever we are adding the values, then that will be not be updated, like whatever the distances it is covering. So, here it is taking the 10 to the power 9 plus 1, and then from here it will take it will also take 10 to the power 9 delay, right? So it is already 10 to the power 9 plus 1, and it can be covered easily. So this distance can be covered with 10 to the power 9 plus 2. This is number of seconds required to travel to n minus 1 comma n m minus 1 cell, right? But in case of this condition, like if we define our distance here as int n comma m, right? And if we will give all the values as 10 to the power 9 for giving maximum value or infinite value, in that case we will lag to keep track of these test cases. So here we will not take int. Instead of int we will just take long, making a range longer. We will just keep it as long, and whenever we will give the value of the arrays, we will just put all the value inside distance as arrays. We will just fill it with long values of 10 to the power 10. So here I will be filled with 10 to the power, sorry, 10 to the power 10. Yeah, right. Even though if we see clearly that we can see that there are maximum how many columns and rows and columns, there can be maximum of 50 and 50. So let's suppose maximum distance can be 10 to the power, let's suppose all the values are there in 10 to the power 9, all the cells are having 10 to the power 9. And if we are getting at 0 at t is equal to 0, then from that position to the next cell it will take, it has to wait till 10 to the power 9 seconds, and then plus 1 will be done to traverse to another cell. And we, as we have already waited for 10 to the power 9 seconds and no more values can be bigger than that, we will max to max add 10 to the we will add max to max 50 to it, right? And then again 50 number of rows, 50 number of columns, max to max. But it is not the case. We can, let's suppose there are more complex test cases there, we have to traverse up down left and right, and in that scenario there can be multiple number of uh, rounded paths can also be there, right? So for that case only we will just keep track of more larger value. That's why we will just take long value instead of just taking 10 to the power 9 plus something, such that it can behave as, what we can say, it can behave as the infinite. So just we will take 10 to the power 10 and long value, because 10 to the power 10 can be accepted in the long form only, right? After that, we have done taking the distance array. We will just go with the priority queue, filling all the values inside the priority queue. So firstly we will take distance of 0 comma 0 will be 0, because it should be uh, the distance array is basically taking the time required to it, right? So it should be kept, the name should be kept as time cost. Okay, total time cost. Okay, set. Okay, so now we will give a priority queue. The first value will be entered in this. So we will add new tuple with values of 0 comma 0, and time cost will be 0 to reach here. And now we will go inside the priority queue and we will track all the shortest time required path, and we will go up, down, left and right. So for that we will take a direction array, 2D direction array. So directions will be int, and here we will take -1 comma 0, 0 comma -1, 0 comma 1, and 1 comma 0. Right now we will go inside the priority queue, we will check until it gets empty, or we will not get the until we are not getting the our destination. So our destination is I is equal to n minus 1 and j is equal to m minus 1, right? So here we will pull out our tuple and pq dot pop, or poll the value. Yeah. So if it dot row is equal to n minus 1 and it dot column is equal to m minus 1, then we will just return the cost, means the it dot time. Otherwise, we will go to check all the adjacent value, and if those distances or time required, time cost is greater than the current calculated value, then we will update that value and put inside the priority queue. So here we will traverse in all the possible four ways. Right. So now here we will keep a current value where it will take 1 to go to next grid or next cell, plus math dot max of either cost or the move time, whichever will be the maximum we have to take that, right? And we will update it if time cost of current value, time cost of I comma j is greater than the current value here, whatever the value we have calculated. If this condition is true, then only we will make sure that that cell should be visited again, and we will add that cell inside our priority queue as a tuple in form of I comma j comma the current value, and the time cost will be updated here as the current, right? So whenever we will get this condition, we will just return the time smallest time required to reach the last cell. So after that, here we will just return 0, because this is the condition. Whenever here only we will return the value inside the while loop only. This case will never come, because there will be certainly a case where the last cell will be visited inside the where priority queue is not get emptied. So let's try to run it. Okay, here a typo. Okay, so firstly we have to check one more condition here, that I should be greater than or equal to 0, and it should be less than n, and j should be greater than or equal to 0, and j should be less than m. Inside this condition only all these possible things should be checked and updated, because this is the boundary, and inside this only we will work, right? It got accepted for the given test cases. Let's try to submit it. Okay, it got accepted. And let's see the third question, which is just the variation of the second question. But the thing is, there is very little difference between these two questions. That here it is given that we are moving between adjacent rooms, takes 1 second for one move and 2 seconds for the next. So, for example, here in the case of this, uh, let's try to see and the notes. So here, as we were moving from 0 to 4, we were taking we are taking at least delay of 4. Then we are going to next cell with 1 uh, second, right? So total 5 second required, and from this 4 to this last cell we are coming with another 1 second. But in that question, in the second variation, here we have to take 2, not 1. So here, so from 4, this 4 to this 4, it will take 2 seconds to travel, because this is the second move. After this second move, we have to again take one. We have to add 1 to do the next move. So this is very similar. So I will just copy paste this solution and we will update all the required things to do this possible solution. So here these are very similar. These two problems are very similar. We have just to take care of the number of moves. So here firstly, in the tuple we have to take care of the moves also, like what is the move, whether it is we have to take 1 second or we have to take 2 seconds. So firstly we will just take uh, as we are at the first position, we will go to next position with 1 second, right? So here firstly we will take 2, such that when we are moving from 0 comma 0 to another one, then we will just take for that condition, for that cell as 1. And after that, from those position we will just make sure that it should be altered each and every time whenever we will make any move. So here we have taken move also, so inside this tuple it will take move also. So here we will just update this dot move is equal to move, and all the things will be same, just here a little variation. And here we will check int temp move is equal to 0. If move is equal to 1, then we will make sure that our temp move should be equal to 2. Otherwise we will make sure that temp move is 1. And here we will not just add 1, instead of 1 we will add temp move, number of temp move. And here also we will pass our temp move, right? This is the only thing we have to do. Let's try to run it and see the test cases got passed or not. Okay, so move is not defined, right? So here it should be it dot move, right? So it is very clear, both are both of the problems are very similar, instead of the single line of difference that moving between adjacent rooms takes 1 second for one move, and 2 seconds for the next, and alternatingly we change the values between those two moves. So that's why we will take care of move, and in each and every move we will just alternate these moves, right? So let's try to submit it. Okay, so it got accepted. So these were the today's weekly contest 422 problems, and I hope this explanation was helpful to you. If you find this helpful, do like, share and comment. Thank you.